So yeah, he already said it. Going to be talking about attacking Google Web Toolkit applications. I'm Ron Gutierrez again. I'm a security consultant at Gotham Digital Science. There's my email and a link to our blog where pretty much everything that I'm going to be talking about today I already wrote like detailed blog post on. So, if for some reason you didn't understand anything I said, you can just go on there and read them. So what's the purpose of the presentation? So why is black boxing GUID apps difficult? I'm sure everyone here has tested typical web applications. We don't need to really go over all that stuff over and over again. And we're just going to go through some reasons why GUID applications are different. I'm going to go over some tools that I wrote and some techniques to make your life much simpler when testing GUID applications. And the presentation isn't really about finding flaws in Google Web Toolkit, but it's rather finding flaws in an application that was developed using Google Web Toolkit. So some motivation. Google released a web application bug bounty. They use Google Web Toolkit to, write some of their apps. You can actually make money out of it if you're able to, use the information from this presentation in order to, actually be able to properly test these applications. So a quick overview. I'm going to do a quick introduction on Google Web Toolkit, just in case anyone here isn't familiar with it. Discuss some of the testing difficulties. Talk about some reconnaissance techniques, how to enumerate all the service and methods that would be called by the application, how to unlock user interface features, and how to actually attack them. So what common web app vulnerabilities apply to Google Web Toolkit. And Google Web Toolkit actually uses a custom RPC protocol when it's sending requests. So we'll talk about how to actually parse them so that you can actually perform some automated fuzzing. So let's start with the overview. So what is Google Web Toolkit? It's a Java framework, and it's used to create rich internet applications. So you're gonna be creating UIs that are, that look like desktop applications. Most of the UI functionalities all run on the client on your browser, and it's only ever making requests back to the server just to get data from it. And one of the interesting things about it is that both the server and the front end are coded in Java. So you still have access to the Java debugger when you're writing your front end. And Google actually created a Java to JavaScript compiler. It takes your front end Java code and turns it into JavaScript, and it actually takes care of all the. It actually compiles it numerous times for different browsers. So since you're just coding it once in Java, it'll be, it'll actually work in every single browser. So some benefits. Why would a developer actually use it? Why would an enterprise place actually consider using GUID? There's a lot of code reuse between the server and the client. Since the front end is coded in Java, you're able to create like custom classes like a user where they store your role, you store some data on that user, and then be able to actually make calls to the server, just by calling the method and passing strings, passing actual Java data types across the wire. And that's where the RPC mechanism comes. Since now you're talking from JavaScript to Java, there has to be a way for the JavaScript to serialize those Java objects, send it over the wire so that the Java server knows how to handle it. And it really allows you to create complex and visually appealing front ends easy without having to worry about cross-browser headaches. I don't know about you guys, but every time I try to use CSS to create a website, I pretty much want to kill myself. So a lot of people go to these JavaScript frameworks or Google Web Toolkit because they're coding in a language they understand. It's Java. You have access to the Java debugger. You don't need to worry about writing these complex Java script front ends. Let Google turn my Java code into the JavaScript and let it work, and they handle all the cross-browser headaches. Make sure it works in Opera, IE, Firefox, so on and so forth. They provide you a lot of widgets and extensions, so they give you a lot of. They're pretty much writing a lot of the code for you, and you just got to focus on the functionality. And no browser plugins, all JavaScript. So it just works out of the box. So now let's talk about the bootstrap sequence. When the user makes a request to the GUID application, first thing you're going to see is that it's going to be downloading a nocache.js file. And what this nocache.js file is really doing is just running some JavaScript code that detects your browser. And then it's going to go and download an HTML file, a cached HTML file that, depending on the browser. And there's going to be numerous cached HTML files for different browsers. And this, the cached HTML file actually contains all of the JavaScript for the front end. So in a typical Java application, you see that all the presentation logics usually run on the server. So user makes a request to a site. Server, determines this guy's a read-only user, send back the UI that a read-only user should be able to see. But with GUID, all that front end is actually compiled into the JavaScript equivalent. So no matter what user you are, you have access to the entire, front end code. But it's not that simple, since the JavaScript code is actually obfuscated using some proprietary obfuscation method that Google created. But we still want to, that JavaScript code does contain some valuable information. It has information on all the service, the RPC service endpoints, any custom object structures, restricted or hidden UI functionality. And, one of the topics that I hope to cover is how to go past this obfuscation in order to, get some more information on the app. So the RPC, it's, I already discussed this. It allows the JavaScript to actually communicate with the Java, serializes these Java objects over the wire, and then when the server side is actually sending back data to the JavaScript, it's serializing it using JSON so that the JavaScript knows what to do with it. So everyone likes pretty pictures, so here's exactly what I just went over, but with pictures. So my browser, I want to call this greeting service method, greet server. I'm passing a string. The client-side code will serialize it, and it'll generate an RPC request payload. That's how a typical good RPC payload would go. It's just a plain text pipe delimited string. Sends it to the server. Server parses it, deserializes it, executes the method, and then sends the response, JSON serialized, back to the browser, and then the JavaScript takes it, knows exactly what to do with it. So let's recap some of the obstacles that you'll probably encounter. Client-side code is obfuscated by default. RPC request payloads are serialized in a custom format, and dynamic web app scanners, your burp scanners, your web scab or whatever, they're just not going to work. They're going to see it doesn't really use the typical request format that it's expecting, like the name value pairs. So when it sees the RPC request going over the wire, it's just going to prepend that request with whatever attack string it is, and it's, the server's not going to even use that value, and it's just going to keep returning the same thing every single time. And security assessments usually have to be finished in a short time frame, 1 week or so. And you really don't want to be trying to figure out how to deobfuscate GUID. You don't want to be, worrying about how to write a fuzzer in that time. So I've already, I've done a couple of GUID applications, and I ended up doing this work. So that's why I'm here, throwing up, giving you guys the info, giving you guys the code, and let you guys, hopefully it helps you guys if you ever encounter a GUID application. So let's start with some reconnaissance. What kind of recon do we actually want to do? We want full application coverage, so we want to be able to test every single service, every single method, and every single parameter that is sent over the wire. If for some reason, you're only given access as a, one user, but there's some admin functionality that's occurring, but you're not really seeing it, I want to provide you a way to know if there's any admin methods, if there's any methods that, that maybe they haven't removed from the front end, and it can still be called on the server side. and how to unlock, hidden and restricted functionality available in the UI. So, all the JavaScript code has, all the role, has the ability to display the UI for all different roles. So I'll just give you some tips on how to actually, unlock it. So let's start with the enumeration. So the JavaScript code is obfuscated by default. It's minified, so the size is reduced. This is all for, just Google being Google and wanting to, be able to send as little data across the wire as possible. You can actually also compile it in pretty mode, which actually displays the JavaScript in a more human readable format. It'll look much more like the Java code that you wrote. And then there's a detailed version where even the variable names will appear in your JavaScript code. It'll be, if you were to put them side by side, it'll look very, very similar from Java to JavaScript. So let's talk about the actual obfuscation that Google performs. The functions and variable names are all renamed. The white space is all removed. Functions are all reordered based on their size. And string values are all stored as global variables towards the end of the file. So here's a pretty version of a typical GUID RPC call, the JavaScript version of it. Some things you might find interesting are, there's that thing I highlighted in red, the method colon, and you'll see that's actually going to contain the service and the method that's going to be called. And then if you look inside of the try block, you're going to see that it's actually building the RPC string that's going to be sent over the wire. So you'll see the full name of the service, the method name, and then you'll see 3, which is I'll talk about it later. I'll go into depth on how the actual string, the structure of the RPC string is. But 3 actually stands for the number of parameters that are being sent into that method. And it just keeps on appending and building the string until it actually performs that request. So here's the obfuscated version of it. I added white space so that you can actually be able to see it. Typically it'll just be one large line. So same exact method, just obfuscated. You'll still see that method colon, but this time the string values are now a variable. So now instead of seeing the service and method name, you'll see OI. And then if you look inside of the try block, you're seeing that the functions are functions were renamed and string values were renamed as well, but it still has the same format as we previously saw. So, through the magic of television, let's say I actually, figured out what OI was by looking in that thing in the cached HTML file. You'll see that it'll actually resolve to the value that it's supposed to be. But realistically, are you really going to be going through this giant cache.html file trying to find these methods and manually doing all this? Probably not. So I wrote a quick script in Python that will actually go through the cache.html file and enumerate every single method call and parameters that method call is actually expecting. And the way I wrote it is, if you recall earlier, I talked about that nocache.js file. So you just pass it in. It'll download one cache.html file. It doesn't really matter which one it is. And then it'll just use some regular expression work and just go through it. And source is available. I put it on GitHub, or is it GitHub? Not sure how it's pronounced, but yeah. Has proxy support, basic auth, cookies, and you're really just passing in the name of the nocache.js file. So once I run it, what am I really looking for in the results? So you're really looking for some admin method calls, any uncalled methods, any testing for unauthenticated access to these methods. Some questions to ask are, are the cache.html files accessible by unauthenticated users? Is the login functionality of the application implemented in GUID RPC? If yes to any of these, the cache.html files, are going to be leaking out all the method calls, unauthenticated. And then it's just up to you to actually be performing those requests. So I'm just going to show a quick demo of the tool. I like videos, so bear with me. So here's a site. It's called Synchronize. It was on a Google GWT showcase. Decided to test it out. So they have a login page. Let's attempt to log in for test.email.com. Put in a couple things. Able to log in. I have my burp running in the background. You'll see the nocache.js file that I discussed before. You'll see that it's obfuscated. And you'll see the next request, which is the cache.html file. And this actually contains, all of the, all the JavaScript that the application is actually running. It's typically a large file, no white space. And then you'll start seeing some of the RPC calls, pipe delimited values. So this is the one I just performed, this auth service call. It's a login request. You'll see the test.email that I sent. So now I'm just going to copy the URL for the nocache.js file, go to my command line, use squiddy-noom to pass in the nocache.js file. Run it. And then let it work for a little bit. It's quite slow. So downloaded it. Now it's analyzing it. Notice that I still haven't even authenticated to the application as well. Grab a coffee or something.
So if a good application has more than one role, has many roles per user, what would be the preferred way of making the application that divulge user interface for roles that you're not supposed to know about?
I don't know. That's a good question. He asked. So let's say the GWT application, does have multiple roles. What would be the proper way to, deal with that? Without giving out all that information. The user's a read-only user. I don't want him knowing that there's an admin role that has access to, admin functionality. The thing is, leaking out that information isn't the bug. It's more of, now that you have that information, you can actually test it, but you really need to be enforcing it on the server side when you're actually performing the call. So that's with this tool, you can at least have the information and know how to be able to test it. So, I finished running, and you're able to see that there's a whole bunch of methods that are available. There's some auth service, create login user, get invitation, login, reset password. This is all stuff that would really be interesting to an unauthenticated user to know and be able to test for, and you try to find some really good bugs. Oh, sorry.
So these are only the methods that are used between the client and the server.
Exactly.
Not anything on the back end, right?
Exactly, just between the client and the server. So, you have this information. How do you actually craft that request? As we saw earlier, the data is actually, serialized. How am I supposed to know how to craft the request and send it over the wire? There's one way you can either, if you do have access to the application, you can see it over the wire, and and then just copy and paste and manipulate whatever you want. Or you can actually create a GWT RPC client. Some folks at GDevelop created it's called Sync Proxy, which they implemented the client in pure Java. So it allows you to, from pure Java, be able to call these methods from wherever. A couple things, cookie support for it is lacking. Kind of requires you to actually log into the application, so it captures the cookie. I was able to modify the code so I could just submit my own cookie, but I didn't really want to release that since I really didn't develop it. So, it's definitely possible, not hard. If you don't want to do that, you can just use Sync Proxy to generate the RPC request, pass it through a proxy, see the request over the wire, and then you can just copy paste it into your burp repeater or whatever you're using. Here's a quick example of a sync proxy. So it's pretty simple. Just specify the class. You pretty much have to create the class in Java, but just as like an interface, you have to use the same fully qualified class name. The URL and the method you're going to call. The method is greet. And then you actually just perform the requests. And then pass in, right here I'm passing in 2 strings and an int. It'll perform the request for you. So let's discuss some more reconnaissance, how to unlock some UI features. All the client-side code, again, is compiled and loaded by the browser. So what if the front end, displays different functionality based on a user's role? Typical web app, we discussed this already. They make a GET request, they receive the request, the server determines their role, and then it executes the presentation logic, what menus to display, so on and so forth, and then returns that to the user. User probably won't have an idea of what's being done, what's actually available in the application. For a GUID app, the way they actually do this is that you have the UI, they ask the server, what role is this user in, or once you log in, it'll return a user object containing a flag in there of what role or what menus you should have access to. So now, for GUID applications, you ask what role, and then it sends back the JSON response containing what role you have. So since it's, now you have to actually pay attention to all the response data that's being passed back, and keeping a, go through it with a fine-tuned code and try to manipulate any integers that are being passed back, any strings that look suspicious, like read-only, for example, or admin service, and then you manipulate it on the way back so that your JavaScript code will actually render different UI functionality. Just talked about this. Manipulate it on the way back, trick the client into showing you the functionality. It seems pretty trivial, but a lot of people just don't think about it. And it's a really good way to just do some authorization testing. It's much easier to have a link that says admin, be able to click it, and then test to see if that page is accessible anonymously, and be able to perform the request like that. Here's like a real life example from a pretty big GUID application, which will remain unnamed. So, you log into the application, and then on the way back, it returned this JSON where it's just, has a matrix of different names and, like false, like different flags, and the matrix is called capabilities. So obviously, that's rung out to me. I'm like, okay. So with using burp, I could easily just write something. Not write something. It has the ability to like search and replace your requests as you go. So just writing like turn all falses into trues on the way on all responses, and then you'll be able to see your UI will just show you functionality of the entire application, and then you can just go ahead and go crazy and be able to test it without any hassle.
Does the backend not verify that when like a
Well,
privileged user?
Well, you have the UI available. It's up to the, when you're actually performing that functionality, that's when the server side has to come in and be like, that user isn't supposed to have access to that. But,
This application.
I don't know, maybe not. It's, so, actual attacking. So GUID RPC, they're typically vulnerable to the same types of server-side vulnerabilities as typical web apps. This is still a Java backend, still going to be vulnerable to like SQL injection, path manipulation, all that. So I really don't need to go over that. But what about like stuff that's actually run on the browser, like cross-site scripting? What about like CSRF protection? We looked at a string. There's some crazy like long hex values being passed over the wire. Are those CSRF tokens? Who knows? So in reality, the way GUID actually does have CSRF protection, but it's through a header that they set, a GUID XGUID permutation HTTP header. And it's not really passing a unique value over the wire, but it's still checking for it. So it's going to be sufficient protection because you can't submit forms and set these headers. You can't really use XML HTTP requests since SOP is going to stop you. You could set these headers through Flash, but then it's still going to require you to have a misconfigured cross-domain policy file. And if you do have a cross-domain policy file, you probably have bigger things to worry about than a CSRF attack. So since it does have CSRF protection, most GUID applications are, well, all GUID applications are not, well, most GUID applications are not going to be vulnerable to reflected cross-site scripting, but they could still be vulnerable if they're not always using GUID RPC. They could still, GUID does provide a request builder that allows you to make requests to arbitrary servlets or even like any server-side thing like PHP or whatnot. And then those requests, you'll just be testing this typical way you would do it, and a web app scanner will be able to find those bugs, so who cares? But GUID applications could still be vulnerable to stored cross-site scripting. The client API does provide ways to render HTML. So, as long as you can perform a request, pass in XSS strings, depending where it's being rendered out, you still have to be careful of how it's being rendered out. If it's being rendered out in HTML, it'll of course be, and no encoding or validation was performed, it'll of course be vulnerable to cross-site scripting. So let's get into some request fuzzing. So the request payload, we talked about it before, it's a plain text, pipe delimited serialized string. And they're separated into 3 parts. It's a header, string table, and then the payload. So the first 3 values are the header. Then we're going to have a whole bunch of values that are going to be called the string table. I'll talk about later how to determine how long that is. And then we have a payload of numeric values. First value is a serialization version. This is checked by the server to make sure that the client is serializing it using the same version that the server is expecting. So if the server is expecting version 4, version 3, and you're passing in 5, it'll obviously return an exception. Skip 0, so some flag value that I'm not quite too sure what it actually does. Pretty much always set to 0 when I tested it. So I'm skipping it. 8 is the size of the string table. So the next 8 pipe delimited values are going to be the string table size. So take those 8 values. I'm going to put it into this nice little text box. No, I did not start it with 0. Just bear with me. And these values are actually going to be referenced by the payload, that set of numeric values at the end of the RPC string. And what the payload actually does, it reconstructs the method call using those numeric values. So there's a payload on top, the 1, 2, 3, 4, whatever. And then so first value is 1. It's going to read the first value of the string table. 2, which is a strong name. It's not really a CSRF token. This value is going to be the same across all the users, and it's only ever really recalculated when they recompile the application. Then you have the service class, the method it's called, and then you see 2. 2 refers to how many parameters that method call is actually expecting. So then we read the next 2 values. Those are going to be the type, the parameter type of the 2 parameters it's expecting. So in this example, it's sending over a string and an integer. Then 7, you read the first parameter value. It's my input 1. That value is fuzzable. I'm not sure if fuzzable is a word, but I like it. So that's the first value. Then the next, you read in javalang int. What this is telling, what this is used for, saying, I'm going to be reading it in an integer next. All numeric values are going to be stored in the payload. So then instead of reading it from the string table, it's actually going to read it from the payload. So once it reads this value, the next value is actually the second parameter that's going to be submitted, so the 1. And this is a numeric fuzzable value. So, you can't really submit a string here. It's just going to throw an exception. You have to, the only way you can really manipulate this is to submit another value. And these are really like places where you're going to be performing like parameter tampering, looking for parameter tampering bugs. So yeah, that was a pretty simple example, but there's a whole variety of different Java types that can actually be serialized. You have all primitive Java types, arrays, lists of all those types, maps, custom objects that can be passed over the wire. What if you see this being sent over the wire? It becomes much more difficult to actually, manually go through every single request done by the application and try to figure out what was sent over the wire. And, if you're going to be fuzzing it, you don't want to be fuzzing every single pipe delimited value. You're going to be creating so much output that you're not going to know what to do with it. Like 90% of the fuzzable values are going to be returning exceptions because it's just not the right format. The smart way to actually fuzz these things is to identify the user input first and its data type, and then test it. If it's a numeric value, only send numeric values. So I wrote another tool called Gutierrez, another Python script which actually parses and identifies the user input for you. And it supports multiple forms of output so that it, hopefully you can use it in another fuzzer. And the source code, once again, same place. Some options, like P, which tries to output in somewhat human-readable format. So if you run it on a string, it'll tell you, how many parameters, what are the parameter types it's sending, what are the values that it's sending. S is a surround value. It'll take the RPC string and surround the values with whatever you want. So if you want to surround it with, the word fuzz me, you can do that. R for replace value. It can replace any user input with a string that you want of your choice. B for burp intruder output. If you're familiar with burp intruder, it has that double S thing, not sure what it's called. It'll actually surround the values with that double S sign, so you can just copy paste it into burp intruder and run whatever fuzz strings you want on it. I, that's where you pass in the string, the RPC payload string, and I have some options to write the output to a file. The reason I added that in is because some terminals can't handle that double S value, so you can just write it to a file and copy paste it from there. So some limitations of Gutierrez. It only really works for the following types for now: primitive Java types, all the primitive Java types and objects, strings, arrays, lists, vectors, linked lists of all primitive Java types, and custom objects, as long as it's a simple custom object, not like a nested custom object within a custom object within like 4 arrays or some crap like that. And I only tested it for serialization version 5. In older versions of Gwt, they actually have different pipes, different delimiters, so it won't be able to handle those. So a quick demo of how to use Gutierrez and use it for burp intruder. It's one of my favorite ones to use. So here we have my little test app. Just my string, RPC string. I'm going to submit it an intruder. You'll see that it fails terribly. It's just going to put the double S thing in the back. You won't be fuzzing anything. So first, I will paste in my string. I used the P option just to show you how the output would look like. I'm not sure if you guys can actually read it, but it tells you how many parameters there is, and it tries to list out in a somewhat human-readable format. I'm kind of lazy and just use some Python things to throw out a class object. But the first thing it says, is array true? So it's an array. Type name is a string, so there's an array of strings, and then values has hi there and Gwt user. It's an array of strings with passing in 3 strings. And then the second parameter is it's an I. I stands for integer, and the value is 2. So next, And also, just by default, I just replace all the string values with %s and all the numeric values with %d. So you'll see in the little fuzz string in the bottom that all the values are replaced. So now I'm just gonna show you the other options to replace. So first I'm gonna do surround with less than fuzz me greater than sign. And you'll see in the results the strings are actually replaced, surrounded, by the words fuzz me. So if you have a fuzzer that actually looks for that, you can just throw it in there. Next I'm going to do just a burp output, write it to a text file. Got my text file. You'll see it now has the format that burp intruder is actually looking for. Just copy, paste it, and then go crazy with whatever payloads you're going to use for the app. So the GUT parser class can actually just be used as a standalone API. Quick example, just create the GUT parser object, use the deserialized method, pass in the string, and then just read the fuzz marked variable, and it just returns a list of all the indices of that string, with the pipe delimited string that you want to be fuzzing. So if you were using Python, for example, you can just get the string, do a split on it, and then exactly which index is going to be the one you're going to be fuzzing. Let's say you want to write an automated fuzzer. A colleague of mine, Marcin, wrote a burp API. Basically what it does is you can, I'm sure everyone, if you're using burp, you typically do a quick crawl of the application. You have your burp logs. This will just parse the burp log into Python objects. So now you can just write a quick fuzzer and go through the entire burp log, find every single RPC request, and automate the fuzzing for the way you want to do it. And it's a pretty useful tool for just creating quick and dirty fuzzers, web app fuzzers at least. And source code is available on GitHub. So use the burp API to filter out all the GUT RPC requests from the burp log. Use GUT parser on every single RPC string that's passed, and then you can actually start programmatically fuzzing each thing. So I wrote like a quick fuzzer, like just a proof of concept kind of thing. And by proof of concept, it's like it's not a crazy tool. I just wanted to show you guys how you would be able to write an automated fuzzer. It does do some fuzzing. It's not polished or anything. But so here's some options. So B for passing the burp log, F for passing a fuzz file, which is a text file that has whatever fuzz strings you want to use. E for an error file if you want to look for specific error messages. O for where you want a directory you want to output all the results to. K for cookies, P for proxy, I for ID range. This is if it ever encounters a numeric value, it's going to do some parameter tampering testing. Whatever you put in ID range, let's say you put 500, it'll test 500 values above the numeric value it read and 500 values below that value. So then, if you're looking at the results and then you see that every time you submit an ID, you're getting different response sizes, you'll be able to see, this looks suspicious for parameter tampering. So let's quick demo of this fuzzer thingamajig. Seems like I have a different terminal each time, but so here's my fuzz file. Just doing some simple SQL injection strings. Error file, looking for some simple SQL injection error messages. Here's my crawl file that I burp generated. It has a bunch of different methods that were called. go back in time. All right, sweet. So, I'm passing in everything. If you look at the I option, it's 5, so 5 integers above, 5 integers below for testing all the numeric values that are sent. And I'm passing it through a proxy because I never, GUID actually, gzips all the JSON responses, so I never really handled the unzipping part of it. So I let Burp handle it for me. So I'm just passing it through my proxy so I don't have to deal with it. So I run it, parses it, fuzzes it, and then it saves the results into whatever I saved it. So go in, it creates 2 HTML files, one called GUIDFuzz, one called paramanip, and then a folder called the responses. Responses just has the raw response data, and the HTML files will just put it in a pretty way so you can actually know what's in there. So let's look at the first HTML file. This is so it just creates a table keeping track of the method call, the attack string called, and the response size, the response status and size. Highlights every single time a error message was found that you specified. So in these cases, I submitted one apostrophe, one. And you see unclosed quotation mark. That's usually an indicator that yes, this is vulnerable to SQL injection. If you look here, no, this isn't it actually. Yeah, incorrect syntax there. It's another SQL injection. So here, you'll see it actually, it's the typical 1 and 1 equals 1 and 1 or 1 equals 1. And if you look at the response sizes, they're much different. The 1 and 1 equals 1 is 48, and the 1 or 1 equals 1 equals 1, 2, 2, 3. And this is a pretty keen indicator that it indeed is 100% vulnerable to SQL injection. So next, I'll look at the parameter tampering results. Here, I'm just really looking at the response sizes to see if there's anything changing dramatically. And then we get to a point where, yes, we found a point where every time you submit a different number, we're getting a completely different response size. You can't always assume that this is definitely a parameter tampering bug. Maybe that's how the application is actually designed, but it gives you a place to actually start looking, and from there on you just do some manual analysis. So 1, 2. The method's called getAccountInfo by user ID, and we get different JSON responses based on the user ID. I think that's it for this video. I think that's it. These are links to all of my different blog posts. Thanks for coming, everyone. I'm not sure how much time I have left.
We've got about 5 minutes for questions.
Anyone have any questions? The way that his question was the way the obfuscation returned to the client, is that how is it controlled? It's whoever's compiling the application, there's an option to say obfuscate it, do it pretty, do it detailed, and usually they only ever change it just for debugging reasons. If you're testing something on QA, you might have a chance of seeing it as pretty or pretty or detailed, but you rarely ever see it, in a live application. And it's all for like performance reasons. You don't want to be having these large cached HTML files. Light is very bright. All right, thanks everyone.